This is the video for the first notebook for graphing inequalities. So graphing inequalities are just like graphing equations, only they're a little bit different. They are going to have an inequality sign instead of an equal sign on this equation. So what we do is we graph it just like we would if it were an equal sign. So we look to graph the line y equals 3x plus 1. The only difference is that if you look at these two statements, we have to choose a dotted or solid line based on the sign. So if the inequality is a less than or a greater than sign, we're going to use a dotted line. If it's a less than or equal to sign or a greater than or equal to sign, we use a solid. So for this certain equation, we are going to be using a dotted line because it's just less than. So we're going to graph this equation like we would normally. The y-intercept is positive 1, so we're going to plot that point, and the slope is 3, so we're going up 3 over 1. I'm going to do another point, down 3, left 1. So when we connect these points, we have to use a dotted line. So mine are little dots, but any kind of dot works, and we connect them with arrows at both ends. So I used a dotted line, and I graphed as I would if it were an equal sign. The next new step number 2, is to pick a point that's not on the line. I always pick 0, 0 unless that's on the line. In this case, it is not on the line, so I'm going to pick it. Then we plug it into the inequality. So that point is 0, 0. So I'm plugging in 0 for x and 0 for y. And we have to see if this statement's true. 3 times 0 is 0. So that cancels out. And is 0 less than or equal to 1? Yes. So if you look at step 3, if the statement is true, shade that side of the line. So I'm going to shade where that point that I tested it was. Had I tested it and we got something like 0 is less than negative 1, that would have been false. And we would have shaded the other side. So let's take a look at the next slide for another example. Right, so just like we did in the first one, we're going to graph it if it were a regular line. So pretend there's an equal sign instead of an inequality sign. So we have a y-intercept of negative 4, so we're going to plot that, and a slope of 1/2. Now now we can erase our equal sign. Because it's just less than, we are going to need a dotted line. So I'm going to use a little purple dotted line. My next step is to pick a point and test it. Again, I really like to use 0, 0 because it keeps it simple, so I'm going to test 0, 0. Now let's see if it's true. 0 is less than 0 divided by 2 minus 4. Well, 0 divided by 2 is just 0. Is 0 less than negative 4? No, that's false. So I need to shade the other side because it was a false statement. That point is not a solution to the inequality, so I cannot shade that side. The shaded region is where solutions lie. So I need you to go ahead and do the U-try on this page. This next slide is graphing inequalities in standard form. So this is still the same way that we are going to do for the other ones, where we just change it to an equal sign. Now normally when it's in standard form we use our intercept table, so we're still going to do the same thing here. 0 for x, 0 for y. When I plug in 0 for x, I get y is equal to 6. And when I plug in 0 for y, I get x is equal to 6. I have 2 points, 0, 1, 2, 3, 4, 5, 6. And 6, 0. So now we have to think about what kind of line we need. Because it's a greater than sign, we need a dotted line. You can't do a solid line unless it's or equal to. So I'm going to connect those 2 points with a dotted line and arrows at both ends. So now I'm going to pick a point to test. 0, 0 works because it's not on the line, and plug it in. 0 plus 0, because both my x's and y's are 0, is greater than 6. Is 0 greater than 6? Heck no. So we shade the other side. So the solution is any point that is in that shaded yellow region. Let's look at the next one. Let's make our intercept table, and then we plug in 0 for x and 0 for y. When we plug in 0 for x, we get y is equal to -1. And then when we plug in 0 for y, we actually get x is equal to -1/4. So this one we might have to convert to slope-intercept form. We do know that the y-intercept is -1 though. So I'm going to subtract 4x from both sides. So I get y is less than or equal to -4x minus 1. So I have a slope of -4. If I go down 4 over 1, I go off the grid, so I'm going to go up 4, left 1. So I still have my negative slope. This is the first example we've seen where we have a less than or equal to sign, so we need a solid line. That was a little off. Alright, so I have a solid line this time with arrows at both ends. I'm going to test the point 0, 0 again because it's not on my line and it's the easiest one to use. Is 0 plus 0 less than or equal to -1? 0 is less than or equal to -1? Nope. So we shade the other side. Right, so the solution is in the yellow shaded region. Go ahead and do the U-try, and that's it for your homework tonight.